Hello and welcome to this tutorial on commonly used statistical tests. Researchers often need to identify which statistical test should be used to analyze their data. So it's important to have a series of questions in mind about the data, and these questions will guide you through decision trees to identify which statistical test is best for your particular data set. So a few things that we need to unpack are: what is the level of measurement? What type of hypothesis are we using? How many measures do we have? And are the measures independent or correlated? The 4 levels of measurement are nominal, interval, ordinal, or ratio. So first we want to ask ourselves, what is a level of measurement, or what kind of data does my particular instrument yield? Next, we want to ask ourselves, what is the hypothesis? Is it a hypothesis of association or a hypothesis of difference? In other words, are we looking for a connection or a correlation between variables, or are we looking to detect differences, such as between groups differences? In psychological research, a lot of times we're looking for a correlation. Let's say, is there a connection between generalized anxiety disorder and chronic depression? Or we're looking for a difference. Is there a statistically significant difference in depression levels for clients who participate in CBAS treatment versus clients who participate in CBT therapy, or more general CBT? So with experimental research, we're looking for either differences between groups or differences between populations in a sample. And then if we are dealing with the hypothesis of difference, we have an additional question exploring whether samples are independent from one another, which is what we would see in the case of a treatment and control group, or whether they're dependent, which is what we would see in the case of a pre-test, post-test. We also want to know, how many measures do I have? If I have 2 measures, I may be dealing with a t-test, which identifies the difference between means. If I have more than 2 measures, I might be looking for an independent t-test, or, if I have more than 2 measures, I'll be using something like a one-way ANOVA. If I have 2 measures, I'm either using an independent t-test or a dependent t-test, depending on whether those measures are independent or correlated. Okay, so again, 2 measures is a t-test to identify the difference between 2 means. More than 2 measures is a one-way ANOVA. And then this is what the decision tree might look like. This is adapted from Sprint Hall 2007. So we start with, what is a level of measurement? If it's nominal, we use this chart. If it's ordinal or ratio, we'll proceed to one of the next charts. So if their data is nominal, where, for example, 1 represents treatment group and 2 represents control group, or 1 represents female, 2 represents male, then our next question is, are we looking at the hypothesis of relationship or the hypothesis of difference? If we're looking to see, is there a difference between the way males and females are impacted by another variable, we might use the coefficient of contingency. If we're looking at the degree of relationship, we might use the McNemer's test. If we're dealing with correlated samples, if we're dealing with independent samples, we might use a chi-square. If we have ordinal data, which is rank ordered data such as class rank, then we ask, are we dealing with the hypothesis of difference or relationship? If we're looking for differences, such as between groups differences, then we would go on to ask, is the group independent or correlated? So if we're dealing with an independent selection, like a treatment group and a control group, where the 2 groups are totally different and they're not connected with each other, then our next question is, are we looking for 2 measures or more than 2? So for example, our research team has been working on an empathy workshop to look at the impact of an empathy workshop on counselors' empathy levels, emotional intelligence, and attachment-related anxiety. When we had a treatment group and a control group, and we wanted to compare the 2 groups, that was an independent selection. Now, if we were looking from pre-test to post-test and wanted to look at differences within a group, we would have to pair the scores for each participant, pre-test and post-test. That would be considered a correlated selection. If we were just looking at 2 measures, and we're looking at empathy levels for both groups, and we had ordinal data, then we'd use a Wilcoxon T. If we had more than 2 measures, like let's say we're looking at empathy and self-compassion, then we'd use a Friedman ANOVA. Going back to the second question, if we're looking at the hypothesis of relationship and we're trying to figure out, is there a connection between empathy and emotional intelligence, or is there a correlation, and our data is ordinal, then we would use the Spearman-Rowe. Most commonly in psychological research, we see interval data and ratio data. These two are combined and called scale level data in SPSS. So once we know we have interval data, which was the case for our empathy workshop, then we go on to the next question. Are we exploring the hypothesis of difference or the hypothesis of relationship? If we're exploring the hypothesis of difference, we have to ask whether our selection is independent or correlated. If we're dealing with a treatment group and a control group, then we have an independent selection. Then we go on to ask how many measures we have. If we have a treatment and control group and we have 2 measures and we're looking at the empathy scores for the treatment group, the empathy scores for the control group, then we're going to do an independent samples t-test. If we're looking at the empathy scores for the treatment group from pre-test to post-test, and we're also looking, if we're looking for pre-test to post-test with just 2 measures, we're going to use the paired t-test. If we have more than 2 measures between treatment and control, we want to see how they differed on empathy, emotional intelligence, and other variables, then that would lead us to the one-way ANOVA. If we have a correlated section and we're looking at pre to post test and we have more than 2 items, like we have, let's say, empathy, self-compassion, emotional intelligence, in this case, we would use a within subjects F ratio. Now we go back to question 2. Are we dealing with the hypothesis of difference or the hypothesis of relationship? If we're dealing with the hypothesis of relationship and we have 2 measures, for example, we want to see, is there a relationship or correlation between empathy and emotional intelligence, then we would use Pearson's R if our data is interval level. If we have more than 2 measures, then we would use a multiple R, multiple regression. For more information on how to determine whether your data is interval, ordinal, or ratio, see the tutorial on the 4 levels of measurement. Recommended resources include the Green and Salkin book using SPSS for Windows and Mac, the Jackson textbook Research Methods and Statistics, the what's been called the Cliffs Notes Study Guide, Research and Program Evaluation, Key Concepts of Study Guide, and then the Sprintall Text Basic Statistical Analyses are all helpful resources on this content. I hope you have enjoyed this tutorial, and I hope as you think about levels of measurement and the series of decision trees, this gives you some concepts to contemplate. Until next time, God bless you.